Hello everyone, welcome back to my channel. Today, as part of our ongoing must-do series, we will be attempting the largest sum contiguous subarray. In this video, we'll be talking about all the possible approaches. We'll start from the brute force and then we'll finally come down to the most optimized approach, in which we will be using Kadane's algorithm. It's a pretty simple yet an effective answer for this problem. We will be writing pseudocodes for all of the approaches and then we'll finally code it up. Alright. So let's start with the problem description. Given an array of an integers, find the contiguous subarrays containing at least one number which has the maximum sum and return its sum. So by contiguous subarray, it means that the subarray needs to be continuous. You can't take a partial subarray from one part and partial subarray from second part and then you can sum it up. That is not the case. Okay, the subarray needs to be continuous and containing at least one number, because if let's say you have an array of all the negative numbers -1, -2, -3, -4, you know that as when you increase the size of subarray, your total value is definitely going to duplicate. So it has mentioned that it needs to contain at least one number, so you can actually just pick up the smallest negative value, right? So in this case, -1, -2, -3, -4, you have given -1 as your answer. So yeah, let's take this another example to understand a bit better. You have an array of size 5, 1, 2, 3, -2, 5. So if I talk about subarrays, like the possible subarrays, it might be an answer 1, 2, 3 can give me an answer of 6, 5 can give me an answer of 5. I mean, both of them seems plausible, but what if I consider this whole array as a subarray, right? This can probably be an answer. So it will give me a value of 6 plus 5, 11, -2, 9. So yeah, this in this particular question, this 9 is an answer, right? I mean, like, this is a subarray, a contiguous subarray that will be giving us our answer. All right, so now let's talk about the approaches, right? And what is the first approach that come to your mind? I mean, from the very basic, right? What is the first thing that will come to your mind? I'll say that how about we just form all the possible subarrays, and then whichever one has the largest value, let's return it, right? So what is going to be the logic of that? How exactly do you print the subarray? How do you exactly do you print all the subarrays of an array? That is also a question. So for that, I just need a loop for I equals to 0 to n. It will be used to determine the starting position. Then I'll use another loop for j is equal to not actually 0, my bad. J is equal to I to n. This is used to determine the size of an array, and then you use another array for k is equal I to j, that is used to sort of traverse the array. In this way, your key can be used to traverse all the subarrays, and you can sort of find whichever one has the maximum values. This is also sort of the pseudo code of printing all the subarrays, right? So this will definitely give you an answer, but now let's talk about the time complexity. What is going to be here? So you have 3 nested loops, right? So the time complexity is definitely going to be an order of n cube. Okay, so can we optimize it a bit? Is there any other approach that is coming to your mind? So yeah, we can definitely reduce this time complexity. And how? Using a variable. I'll initialize a variable known as current that will be initialized before the second loop. I'll also initialize a variable, let's call it answer. The current will be 0. Okay, and this current, this variable, the purpose of this variable is to eradicate the use of this third loop. How will you do that? So every time so the value of this current, right, it will basically become current plus I equals to a of j. And at the end of this j loop, right, at the end of this j loop, I mean, why do we need to traverse it? We can simply add those values at current, right? So current plus equal to aj. At the end of this j loop, it will give the answer, the complete the sum of complete subarray. And at the end of this j loop, you can sort of use this type of logic, max of answer comma current, and whichever one of the previous answer or the current value, whichever one of them is the greater, it will be stored in the answer. So you can, at the end of this I loop, you can return this. So this will this current will definitely help you in removing this third loop, and it will also help you in bringing down time complexity from order of n cube to the order of n square, right? Now, can we optimize this a bit more because order of n square is definitely a lot less than order of n cube. So can we optimize this a bit more? And yeah, that is when Kadane's algorithm comes into picture. There are many definition of Kadane's algorithm out there that start with telling them it's a DP, it's a recursive, but from my understanding, it basically wants to say that as long as a subarray has a positive value, keep track of it. Okay, let me explain what I mean by that is, so let's consider an array 4, -1, -2 and 5. Okay, the yeah, and the answer here is going to be 6, by the way. Now let's try to understand how we can implement Kadane's algorithm in this particular array. So for that we need only, I think, two variables. One will be used to track of the current ongoing subarray and one will be used to track of the final answer. Current and the final answer. So current will initially be 0 and answer will initially be the most negative value. So let's call it a min. Okay, so now let's start. You will start from the 0th index, that is 4, and okay, so your current value is basically 4, right? And your answer, what is the logic of answer simply says that it should be the greater of the previous answer comma the current answer, right? So earlier it was the most minimum value, so now it will become 4. Okay, so yeah, you are here, and okay, now I'll come a bit forward. 4 minus 1, 3, right? So the current value will become 3. Now some of you might think, what exactly is the use of tracking this -1? I mean, the previous value was 4 and now the aggregate value has decreased, it has become 3, which is smaller than 4. So why are we increasing the array? Why are we not stopping here? So the reason is very simple. This can be a part of another value that may at the end become even greater than 4, right? Let's try to push a bit more forward. The current value becomes 3. The answer was previously 4, but since 3 is not greater than 4, the answer will remain 4. We come a bit more forward. -2, it is 1, right? Since remember the Kadane's algo, as long as it has a positive value, it is 1. 1 is still a positive value, we will keep track of it. So yeah, but again the answer will remain 4 because we have already encountered 4, right? 4 is a possible answer, and current is 1, so we won't really update the value of answer. Now I'll come a bit more forward. We have 5, right? 5 plus 1, it will give me 6. So the current value becomes 6, and as per the logic of answer, our answer will become 6, right? As you can see, the value was 4, it kept deprecating on and on, it became 3, it became 1, but at the end, this one, it was a positive value, it helped in the final answer. It got added to the 5 and it gave an answer of 6. So that is what Kadane's algo is trying to say. But what if, let's try to take another example. What if I'll try to insert a value of -2 again here. Okay, remember Kadane's algo said that you only need to keep track as long as it has a positive value. So in this case, I would have again started from 4. At this point I would become 3, and this point I will become 1. But what if I again come to this part? At this point I will become -1. So this -1 can help us in no way. No matter where this -1 go, it will only decrease the final answer. So when we encounter any such scenarios, what we will do, we will simply, when our current become -1, we will say that, okay, if it is smaller than 0, make it 0. Making it 0 means that from this point onwards you are taking this as a starting point. Okay, you are simply ignoring the previous subarray because that is giving me a negative value, and this negative value can in no way help my final answer, because everywhere this minus value goes, it is going to decrease the final answer. Very simple, right? So whenever you get a negative value in your current value, you will just say it has become 0. So yeah, that is like the gist of the Kadane algo. So now let's try to sort of write the pseudo code of this. Give me a second. Okay. Okay, I said that I only need two variables. Current, it has an initial value of 0. and answer will have a min value. So every language have, I think, their own. Probably C++ has int and Java also has something. So every language have their minimum value. If you are not aware of this, you can simply just take a value smaller than a minimum constant. Okay, so yeah, now let's start with the loop. You will have a loop that will go from I equal to 0 to n, right? And as I said earlier, your current will add, the current variable will add a value, add the value at which your index is pointing to, and after that your answer will be max of whatever it was previously or whatever it is currently. So that is the logic of answer. And as for your current, if at any given point of time your current is less than 0, you make your current equal to 0. So yeah, this is like complete Kadane algorithm. This is all you need to know. And what is the time complexity for this? So you are only using one loop. The time complexity is now order of n, right? So yeah, now we are going to move to the coding part. But if you have any problems in this, any questions in this, you can put it down in the comment section. I'll try to answer it. All right. So yeah, now let's move to the coding part. So the code is going to be pretty similar. Here I will be using Python language. Let me just change the name of arguments a bit more with what I'm comfortable with. So we only need to value your answer. That will be the minimum value. I'm not really sure about what is the minimum value in Python, so I'll just create it myself. Minus 10 to the power of 7 minus 1, right? And your current will be 0. Okay, then you start with your loop for int range of 0 to n. Right, now let's remember the logic. The current will, sorry, okay, I don't think Python takes that. So current will equal to current plus the a of I, and the value of your answer needs to be updated if the current is greater than answer. So if current is greater than answer, what do? You say answer is now equal to current, right? And if at any given point of time, if current is less than 0, you say that current is 0, and then you finally return your answer. Now let's try to see if it works or not. Okay, so compilation has passed. Now let's try to submit it. Okay, there were a lot of test cases, and yeah, we have passed all of them. So yeah, that is good with us. And cool. Again, if you have any questions, tell me in the comment section. I'll help you in answering them. And if this video was able to help you with anything, definitely do like and subscribe to my channel for the continuous videos. Thanks for your time. Take care. Bye bye.